it's kind of
All right.
into.
So today we're going to talk about related rates. And so there's an illustration there that kind of gives you a picture reference of what a related rate is. And so if you look at that cone is actually holding a liquid. And at the start, in this first picture here, the cone is nearly full. And then what ends up happening is for some reason or another, they start letting water out. And so as that water goes down, your volume in your cone is decreasing, okay, as is your radius. Because as the volume goes down, that radius is going to shrink. And so we're going to look at, like, how much would the volume of that cone, how much of the volume of the water in that cone would that shrink in relation to time? Okay, and so let's go ahead and look at your next slide. And I went ahead and printed off this for you. These are the guidelines, so these are the steps that we go through. And these really pertain to what you did in section 5. So the first step is identify all given quantities and quantities to be determined. Make a sketch and label the quantities. You don't always have to make a sketch. Okay, the biggest thing is you need to figure out what are you trying to find. Now, in some of these problems, especially the first one we look at, this is going to be really easy because everything's going to be spelled out for you. But in some of the future problems, you're going to have to write down what do you know. Biggest piece of advice, you're going to look at the labels. So when you're determining step 1, you need to look at the labels because the labels will indicate what you've got. So the labels are crucial. Step 2, write an equation involving the variables whose rates of change either are given or are to be determined. So now we're dealing with an equation, and once again, you're going to look at labels to help you out. Step 3, using the chain rule, implicitly differentiate both sides of the equation with respect to time t. So yesterday we did with respect to time, or with respect to x. Now we're going to do with respect to time t. Same process. Okay? Step 4, after completing step 3, substitute into the resulting equation all known values for the variables and their rates of change. Then solve for the required rate of change. Okay? So let's start with number 1. Now, if you remember what I said about number 1, we don't really have to identify step 1 because it's pretty much already given. Okay? So we start, with an equation. A equals x squared, and so that's where I'm going to start. And so what I'm going to do with A equals x squared is I'm going to go ahead and differentiate both sides of the equation with respect to what, folks? T. So what I'm going to do is I'm going to take d dt of both sides. So now I need to determine what is the derivative of 1, or of A. There, I just told you. What's the derivative of A? 1. Okay, so now I compare. Do those variables match?
No way.
So I need a dA dt. On the right side, what is the derivative of x squared? 2x. Do the variables match? So what do I need? dx dt. So then now what you need to do is sub in stuff into the equation. So they tell me dx dt is 3. Okay, so that means that is 3. They say x equals 10. So right now I've got 2 times 10 times 3. And I want to find dA dt, which is the right side of the equation. So what I need to do now is just take 2 times 10 times 3. And when I do that, I get 60. Now the question is, I need to label. Now, if you notice, there weren't any labels in the problem, so I'm good to go here. My answer is just 60. But on the next slide, we're going to talk about how you can figure out the label based on what you found. And it's fairly easy. Okay? So that was kind of our warm-up problem. Yes, you have about 2 of these on your homework. And we're going to now go to a word problem. A fire has started in a dry, open field and spreads in the form of a circle. Okay, and so believe it or not, they actually do like math problems like this, only they probably, they have computer programs, but they do like the spread of fires, the spread of diseases. The CDC does that, if a disease hits this location, how long before it would like wipe out an entire population. Okay, and so they actually look at things like this on a larger scale. But we're going to go ahead and look at this. It's going to spread in the form of a circle. That's really important. Okay, the radius of the circle increases at a rate of 6 feet per minute. Find the rate at which the fire area is increasing when the radius is 150 feet. Okay, well, let's go ahead and back up. First of all, we know we're dealing with a circle, right? It says find the rate at which the area is increasing. So I've got area of a circle. That is my main equation. What is the area of a circle? Pi r squared. So that is where I start. Now I've got to go back into the problem and I've got to go back and label some other things. It says the radius increases at a rate of. Now if you remember, what did I say we need to look at? Labels. Feet per minute. So really what this means when this refers to radius, this means dr divided by dt. Okay? Because minutes are a form of time. So really you have your unit of radius divided by your unit of time. So that's where the dr dt comes into play, and that is 6. The other thing that you're given is what? What is this? This is 150. Let's look at the label. It's feet. So I know that this is just a one without a dt. It's just a plain one. In this case, it's r equals 150. So let's go ahead and try and solve and see if we have enough information and if we can finish the problem. What is the very first step? Oops, let's change colors. The very first step is take d dt of both sides. What do you get on the left? dA over dt, because the derivative of a is 1. Variables do not match. Okay, now the big question is, what do I do with the pi? Remember, the pi is just a number. Okay, so basically I'm looking for the derivative of r squared. What's the derivative of r squared? 2r. So really this would be 2 pi r. And what else? dr dt, because your variables do not match. What do you need to do now? 6 for dr dt and, whoa. Okay, 6 for, I wrote that in the wrong spot. 150 for the r and 6 for the dr dt. So I end up having 2 times 150 times 6. What is 2 times 150 times 6? 1800 pi. Now this is where I told you that we're going to look at what we're given to find the label. This is what dA dt equals. So I need to think about, in this problem, what would the label for area be? Feet squared. So that's what goes on the top, divided by, what's the label for time? Minutes. So you see how that works? You're just going to do your label for area divided by your label for minute. Or for time, sorry. Okay, so you could answer 1800 pi. You could also multiply that out, in which case it's going to be like 50 some hundred. Okay, 5400, around there somewhere. Okay, so let's go ahead and look at the next question. Gas is being pumped into a spherical balloon. Now this isn't like liquid gas, okay? This is like a helium. Okay, gas is being pumped into a spherical balloon at a rate of 5 cubic feet per minute. Find the rate at which the radius is changing when the diameter is 18 inches. So let's think about that. We've got a spherical balloon. If I'm pumping gas into it, what is changing? The volume. So I need to know the volume of a sphere. Now, one of the things that I gave you is I gave you that sheet with a bunch of the three-dimensional pictures that should have all of the formulas that you're going to need for this assignment on it. Okay? So what is the formula for the volume of a sphere? 4/3 pi r cubed. If I were you, I would probably keep that sheet handy because you're going to need it on your homework. Okay? So now let's fill in what we know and what we're given in the problem. First piece of information they give us is they give us 5. And then we look at the label. Feet cubed divided by minutes. So since I know it's got to be something over dt, I got to think feet cubed. What would that be a unit for? Volume. So this is actually dV dt. So dV dt equals 5. Okay, find the rate at which the radius is changing when the diameter is 18 inches. D equals, now, we got a problem. Yeah, 1's feet, 1's inches. So you got to do what? So what's my D in terms of feet? 1.5. But I don't want D, I want R. So what's R really? 0.75. So that's one of the things you're going to have to look for, is you're going to have to look for a possibility that your labels might be different. You might have to make a change like that. What do I do now? Yep. Differentiate both sides of the equation with respect to t. So on the left side, what are you left with, or what do you get? dV dt, because the derivative of v is 1. Okay, oops, there we go. Now, the 4/3 and the pi are nothing more than numbers. So all I'm looking for is the derivative of r cubed. Okay? So the derivative is actually 4 pi r squared when you simplify things. And then what else? dr dt. So now, last but not least, I need to go ahead and plug in what I know. I know that dV dt equals 5. Oh, so I've got the 5 on the left side. I know that r is 0.75. So then I look back in the problem and it wanted to know how fast is the radius changing. So this is what I need you to do for me. Okay? I want you to just calculate for me the right side of the equation. So 4 times 0.75 squared times pi. Do you get something like 7 or 8? 7.068. So now to solve for dr dt, what are you going to have to do? Divide. Yep. So take 5. Divide it by 7.068. And what do you get? .707, so let's round it to 7.1. So now we need to come up with a label. So remember, for the label, I'm going to look at what I found, and I found dr dt. So in this problem, what would the label for a radius be? Feet. Divided by, what is the label for time? Minutes. So my answer is 0.71 feet per minute. Okay? Pretty straightforward. Questions? Alrighty, this is what you need to do from this section. Okay? Now, a little bit about the rest of the week. Tomorrow, we have our Tootsie Roll Pop lab activity that you're going to do in class. Wednesday, I'm giving you a work day. Remember, your test is going to be Friday, I'm giving you a work day. Remember, your test is Tuesday and Wednesday of next week. Okay, that's your Chapter 2 exam.
Do you have anything to give to